factoring algebraic expressions, also known as factorizing algebraic expressions. Previously, we have covered multiplication of polynomials as well as special products. In this video, we'll learn how to split an algebraic expression into factors. Just like how a bigger number can be expressed into factors of smaller numbers, algebraic expressions can be factored or factorized into smaller expressions as well. Let's take the number 21. We can write 21 as a product of 3 and 7. So 3 and 7 are called the factors of 21. Similarly, algebraic expression can be split into factors as well. You can look at finding the factors of an algebraic expression as the inverse of finding the product. For example, when we have two expressions, namely p, a monomial, and q minus r, a binomial, then p times q minus r equals pq minus pr. So pq minus pr is a product of those two terms. Now, if we are given the product, then we should be able to find the factors. So in the above example, in the expression pq minus pr, the common factor is p. So if you take the common factor out of the two expressions, we get pq minus pr equals p times q minus r. Here the expression pq minus pr has two factors, namely p and q minus r. The factors can be monomial, which can be a constant value or a variable, or higher order of polynomials. In the example above, one of the factors is a monomial, namely p, and the other factor, q minus r, is a binomial. Let's look at another example. Find the factors of 3a plus 9b. The common factor between 3a and 9b is 3. So 3a plus 9b equals 3 times a plus 3b. So the factors of 3a plus 9b are 3 and a plus 3b. Find the factors of 13m cube n plus 65mn cube plus 91m squared n squared. The common factor of the three expression is 13mn. So 13m cube n plus 65mn cube plus 91m squared n squared equals 13mn times m squared plus 5n squared plus 7mn. The factors of 13m cube n plus 65mn cube plus 91m squared n squared are 13mn and m squared plus 5n squared plus 7mn. In all these examples, we found a monomial and a polynomial as factors of the algebraic expression. Let's look at another example. Factorize a times b minus c plus d times b minus c. The common factor here is a binomial b minus c. So a times b minus c plus d times b minus c equals b minus c times a plus d. Here the two factors b minus c and a plus d are both binomials. Let's look at another example. P times q cubed minus 1 plus m times q cubed minus 1 plus q cubed minus 1. Here, q cubed minus 1 is a common factor between the three terms. The third term, which just has q cubed minus 1, can be written as 1 times q cubed minus 1. So this equals p times q cubed minus 1 plus m times q cubed minus 1 plus 1 times q cubed minus 1. Here q cubed minus 1 is a common factor, so this equals q cubed minus 1 times p plus m plus 1. Let's look at another example. Factorize 3 plus 9b minus a plus 3b the whole square. Solution. It doesn't seem obvious what the common factors here are. This requires an extra step to identify the common factors. Let's see how this expression is factorized. 3a plus 9b minus a plus 3b the whole square equals 3 times a plus 3b minus a plus 3b the whole square. Here, a plus 3b is a common factor. The second term has a plus 3b squared. So this expression can be rewritten as 3 times a plus 3b minus a plus 3b times a plus 3b. Taking out the common factor a plus 3b, we get a plus 3b times 3 minus a plus 3b, which equals a plus 3b times 3 minus a minus 3b. Let's look at another type of problem. Factorize xz plus xy plus yz plus x squared. Solution. At first glance, it doesn't look like there are any common factors between the four terms. The way to factorize this expression is by rearranging the terms. Take a look at the expression again. xz plus xy plus yz plus x squared. Let's rearrange the second and third term here as shown with the help of the arrows. This equals xz plus yz plus xy plus x squared, which equals z times x plus y plus x times y plus x. Since y plus x and x plus y are the same, the second expression can be rewritten, and this equals z times x plus y plus x times x plus y, which equals x plus y times z plus x. That wasn't obvious at all, but grouping terms in such a way to have a common factor is a set of problems which gets easier with practice. Let's look at one example with division. Simplify 7p minus 21q divided by 12q minus 4p. Solution. The common factor of the numerator is 7, and the common factor of the denominator is 4. So 7p minus 21q divided by 12q minus 4p equals 7 times p minus 3q divided by 4 times 3q minus p. Here the expression in the numerator can be written as negative 3q minus p. In other words, p minus 3q equals negative 3q minus p. So we can rewrite this expression as 7 times negative 3q minus p divided by 4 times 3q minus p, which equals negative 7 times 3q minus p divided by 4 times 3q minus p. Striking the common factor 3q minus p on both the numerator and denominator, we get negative 7 over 4. That's our first part in the series of factoring algebraic expressions. In our next video, we'll look at factoring trinomials, special products, and other expressions. Thanks for watching.